Hello students. In this class, let us discuss ionization potential. Okay, that is very important question. Of course, most important question, long answer question for intermediate public examinations. Okay, let us see what is ionization potential. What is the question we get? Let us see first. What is the question here? The question is like this. So define first ionization potential and second ionization potential, write or explain any four factors which affect ionization potential. So that is the question. So what is the question here? What are IP1 and IP2? That means first ionization potential and second ionization potential. And another one also there, why second ionization potential more than that of a first ionization potential, and explain any four factors affecting ionization potential. Okay, let us see what are the answers here regarding that. Four questions are here. First one, let us see first ionization potential, that is said to be IP1. What is first ionization potential? Let us see here. So first, if you consider any gaseous, neutral gaseous atom, isolated neutral gaseous atom. So if you want to remove one outermost electron from it, we have to provide some energy. That energy is nothing but said to be first ionization potential. Now after losing electron, it become M plus and electron is released out. So how we can define now here? So the minimum amount of energy required to remove outermost electron from a neutral gaseous atom is known as first ionization potential. So this is known as which one? First ionization potential, IP1. Okay, now let us see what is second ionization potential. So second ionization potential means what here? We have to remove the electron from unipositive cation. Now the energy required to remove another electron from unipositive cation is known as second ionization potential. That is known as which one? Second ionization potential. Now, generally second ionization potential is greater than that of first ionization potential. So what is the reason for this? Let us see here. What is the reason means, if you consider neutral atom, neutral gaseous atom, it is having larger atomic size compared with unipositive cation. So as the size of the cation decreases, the nuclear attraction on outermost electron increases. So now this time we have to give somewhat extra amount of energy to remove that electron. So like that here, as the cation is having, as the unipositive cation is having smaller size compared with the neutral gaseous atom, second ionization potential greater than that of first ionization potential. So like that here, IP1 is less than IP2, less than IP3, so on like that. That means second IP greater than first IP, third IP greater than second IP, so on like that. So this is regarding which one? Why second IP greater than first IP means, we can give two answers here. First one is here, due to the smaller atomic size. Now, nuclear attraction in case of unipositive cation is more on outer electron compared with neutral gaseous atom. And another one also we can give here. Now this unipositive cation is having more number of protons rather than that of, that means compared with which one, number of electrons. As the number of protons are more, that means nuclear charge dominate over the number of electrons. So this is also another reason for the increase in ionization potential while removing the second electron. So like the two answers we can give here. Due to that smaller atomic size, now here nuclear attraction reaches strongly to the outermost electron, and another one due to the increased nuclear charge. This time we have to give more amount of heat energy to remove the another electron. So like that, second ionization potential is greater than that of which one, first ionization potential. Now let us see factors affecting ionization potential. So let us see what are the affecting factors affecting ionization potential. So in that the first one is which one here? Let us see what is the first one here. First one is atomic size. So how the atomic size will influence or affect the ionization potential, let us see here. So now as atomic size increases, ionization potential value decreases, because as atomic size increases, nuclear attraction on outermost electron decreases. Decreases means kam hote, decreases. So like that, as the nuclear attraction decreases, now this electron can easily removed. So like that, as atomic size increases, nuclear attraction over outermost electron decreases. So, ionization potential is inversely proportional to the atomic size. So, this is the first factor which affect which one, ionization potential. Okay, now let us see the second factor which affect the ionization potential. So what is the second factor? What is that means here? Nuclear charge. So see here how this nuclear charge affect the ionization potential. So as the nuclear charge increases, that attraction on outermost orbit increases. Nuclear charge means nothing but number of protons in the nucleus. So now for example, in case of A atom, let us consider 12 protons are present. In case of B atom, 20 protons are present. So now what happens here? As the number of protons in the nucleus increases, nuclear charge also increases. That means nuclear attraction on outermost electron also increases. Now we have to give more amount of energy to remove that electron. That means as nuclear charge increases, ionization potential also increases. So what is the relation between these two? Means directly proportional. So ionization potential is directly proportional to which one, that nuclear charge. Okay, now let us see another third factor which can affect that ionization potential. So what is the third one here? See that what is the third one means screening effect, or we can call this as shielding effect. Screening effect, or we can also call that as shielding effect. So first let us see what is screening effect and how it will that causes effect on which one, ionization potential. So first let us see what is screening effect here. For example, consider the two atoms here, A and B. Now, in case of A atom, in between nucleus and outermost electron, consider two electrons are present. But in case of B atom, in between nucleus and outermost electron, for suppose 6 electrons are present. Now what happens here? See, now these inner orbital electrons try to screen the nuclear attraction reaching the outermost orbit. Here in the case of A, only two electrons are screening the nuclear attraction reaching the outermost electron. But in case of B atom, 6 electrons are screening the nucleus attraction reaching the outer orbit. That means here these 6 electrons can screen somewhat greater extent that nuclear attraction reaching the outermost orbit compared with 2 electrons, because just 2 electrons are here, but here 6 electrons are present. So as inner orbit electrons increases, screening effect also increases. As screening effect increases, this nuclear attraction may not reach completely to that outermost orbit. That means in this case, nuclear attraction is less on outermost electron. So that means we can easily remove this electron compared with this A atom electron. That means what happened here, as screening effect increases, the amount of energy required to remove the outermost electron decreases. That means ionization potential is inversely proportional to the nuclear, that means screening effect. As screening effect increases, ionization potential decreases. So now here ionization potential is inversely proportional to screening effect. So if you want to get clarity regarding this, I give one example here. Let it be the football court A and let it be the football court B. Now here in between players and that football court, only one goalkeeper is there. Only one goalkeeper is there. In which court? A court. But if you come to the court number 2, that is B court, in between the players and the that which one here, that net, some 10 members are standing in line. So now in the first case, this ball is having more probability to reach into that goal post. But in case of B court, as more number of goalkeepers are here, the probability of reaching the ball into the goal post is less. So that means as the inner orbital electrons increases, this nuclear attraction may not reach the outer orbit completely. So this electron could be removed easily. So like that, as screening effect increases, what happens here? Ionization potential decreases. So this is another effect which is affecting which one, that ionization potential. So this is screening effect. Now let us see another one also here. What is that? Penetrating power. What is a penetrating power? Let us see here. Now, if you consider SPDF subshells, as S subshell is having spherical shape, now the electrons present in S subshell having equal attraction in all direction from the nucleus, because that is in spherical shape. So now among all the 4 subshells, the electron present in S subshell is having more penetrating power towards the nucleus, because the electron present in S subshell is equally attracted whether it is present in any side, irrespective of the axis or whatever it may be. That S subshell electron is having equal attraction in all the direction by the nucleus. So for that reason, S orbital or S subshell electron is having more penetrating power. That means that can moves very close to the nucleus. So now that order of penetrating power is S greater than P greater than S greater than P greater than D greater than F. That means here S subshell electrons are very close to the nucleus compared with P. P subshell electrons are close compared with D subshell electrons. D subshell electrons are close to the nucleus compared with F subshell electrons. That means here to remove the electron from S subshell, we have to give more amount of energy. So like that, ionization potential also follows the same order. S greater than P greater than D greater than F. Okay, next. After that, here another effect, let us see. So what is that means? Electronic configuration. So now what is the effect of electronic configuration? Let us see. We know that if any element is having either full filled or half filled configuration, that is having more stability. That means here the atoms, that means the elements which are having half filled or fulfilled configuration, those are having more stability. That means we have to give more amount of energy to remove the electron from them. So example here, chromium. If you consider chromium, its atomic number 24, configuration argon 4s1 3d5. It is having d5 configuration. D5 configuration is what? That half filled configuration. So due to that stability, it is having high ionization potential. And let us see another one here, copper, atomic number 29, configuration argon 4s1 3d10. So due to full filled configuration, it is also having more stability. So copper is having high ionization potential. So these are the factors which can affect the ionization potential. So these are regarding the factors affecting which one here? Ionization potential. Okay, now some competitive questions also there. What are the important competitive questions? Okay, I will discuss only important competitive questions, not all the story here. So what are the important competitive questions? See here. So how many IP values possible for one atom? How many number of IP values are possible? Means IP1, IP2, IP3, like that. That is nothing but equal to its atomic number. For example, if you consider hydrogen, it is having only one electron. So IP1 only possible for that, not IP2, IP3, because after removing one electron, there is no another electron. So the number of IP values are equal to the number of electrons. That means equal to the atomic number. This is the first important question. And what is the another important question here? For example, if you consider beryllium and boron, so now in a period from left to right, as atomic size decreases, ionization potential increases. That means actually IP1 of boron should be greater than that of IP1 of beryllium. But this is controversial to original value. What is that experimental value? Means first ionization potential of boron less than that of beryllium. The question is why this phenomena takes place. Why boron IP1 less than that of beryllium? Very simple reason. Beryllium is having configuration 1s2, 2s2. Boron configuration 1s2, 2s2, 2p1. That means here in beryllium, electrons are present in high penetrating powered S subshell. But in case of boron, the electron is present in less penetrating power comparatively with S subshell, less penetrating powered P subshell. So for this reason, boron IP value is less than that of which one? Beryllium. And similarly, another question also we get here. And if you go like that in a period from left to right, when come to fifth A group and sixth group elements. So generally in a period from left to right, what happens? Ionization potential increases. That means nitrogen IP1 should be less than that of oxygen. But IP1 of nitrogen is greater than that of oxygen. Why that means? Very simple. Nitrogen is having half filled configuration 2s2 2p3. 2p3 means nothing but which one? Half filled configuration. But oxygen configuration 1s2 2s2 2p4. This is incompletely filled configuration. So due to half filled configuration, first IP of nitrogen greater than that of oxygen. But if you come to second ionization potential, IP2, now what happens? Nitrogen IP2 less than that of oxygen. Why? Because IP2 means already one electron lost from that which one? Nitrogen. Now this configuration will become 1s2, 2s2, 2p2. Hey, this is which one? Incomplete configuration. But if you that means if you consider oxygen, what happened here? 1s2, 2s2. After removal of one electron, we got which configuration here? Half filled configuration. So like that here, nitrogen second IP is less than that of oxygen. This is another question we get from ionization potential in competitive exams. And another question is here, what is that? For example, for an element M, IP values are given like this: IP1 less than, IP2 less than, IP3 less than, IP4, like this. Now the question is here, what is the chloride formula of this element M? Options they may give MCl, MCl2, MCl3, MCl4, like that. But how to determine that formula means, let us see here. First observe where the sudden gap is present in IP values. So we have to observe the sudden gap. Now here less than given means in between second IP and third IP there is a sudden energy gap. Why that gap was taken place here? After removal of two electrons, this M element got which configuration? Inert gas configuration. That means this element belongs to second A group. So that means we have to remember a simple point here. After which ionization potential there is a sudden energy gap, that IP is nothing but that number of that IP is nothing but equals to its group number. As here after second IP there is a sudden gap is observed. This element belongs to second A group. Second A group element means that can exist in M plus 2 oxidation state. Its chloride formula means in crisscross method one can give the formula which one? MCl2. So these are the questions we can get in competitive. So in IP, that means in intermediate public examinations, The most important question is ionization potential for long answer. Okay. If you go through this, you can get good score. Okay.